Hello, sir. My name is Nandini. Today I am going to explain about manufacturability analysis is a useful subset of systems engineering. Introduction. The application of manufacturability analysis to the design of mechanical parts in electronic systems improves quality, performance, and reliability. Typical internet areas include equipment enclosures, transducers, and high-tech microwave modules. New performance levels are feasible due to improved surface quality, stability, reduction of seam widths, or the use of sophisticated materials. The stepwise procedure points out attractive solutions for challenging airborne, maritime, or space sensor platform. Hence, a true understanding of manufacturability, judgment, and knowledge about current molding, welding, and coating process is essential, as well as the earliest application of the formulated principle. The complexity of mechanical parts is an electronic device or system may exceed 35% of the total value, ranking from the low-end consumer electronics like mobile phones to the sophisticated space quality remote sensing and military products. Possibilities of improving performance of mechanical sub-assemblies are often overlooked, which might be based on the lack of knowledge about current processing capabilities in the machine industry and the required optimized design principles. A glimpse inside a typical electronics laboratory confirms this statement, starting from the prototype where impedance variation due to a bad connector mounting turn out critical. Things get worse on the production line. Must cost is accumulated or potential performance lost due to poor understanding of modern milling capabilities. It is the basic design steps for manufacturability analysis and the difference between the system process. The exact dimension and geometrical tolerances, surface roughness, and other flaws hardness requirements and joining parameters are defined, classifying the process. Finally, process qualitatively. Cooperation between the designer and manufacturer is needed at this stage. Finally, different methods are compared according to their adequacy with respect to the production volume, recurrence, cost, the level of standardization, and the use of modular construction. The simplified flowchart is given figure. The mechanical subassemblies or individual parts may have three separate and combined tasks within an electronic device or system. Supporting structures are nearly always essential necessary due to the small size and insufficient integrity or electronic components. Their size ranges from a huge 300 meters antenna towers to sub-millimeter transistors. Mounts, shocks, vibration, bending, and loading are the most common problems. Efficient shielding, be it general environment, dust or moisture, or just to ensure proper operation under electromagnetic interference, is mostly left for mechanics. The most comprehensive applications are based on the multi-layer sandwich structure provides a quality, robust, and lightweight enclosure for assembling microwave components. All layers can be of different metal and critical joints are laser beam built. Physical dimensions and carefully designed structures producing the wanted electromagnetic behavior as typically found in various antennas transmission likes and transducers. Manufacturability analysis. Mechanical manufacturability analysis can be through as well defined and more specific subset systems engineering principles. It has four basic stages. First, quite naturally, each mechanical part should fulfill its intended function. Initially, a comprehensive list of functions for each component and for the whole assembly is collected. Second, this is enlarged to include sorting of absolute requirements and possible desires. Comparative limits of manufacturing process are collected beforehand. Using of these Using all these, the designer builds non-viable conditions for the particular processes. Some must be discarded because a functional condition of the final product would be met. Simultaneously, at least a couple of these desires can also be satisfied. A practical application. The design and construction of a microwave transducer assembly carried out by a team of electronics and mechanics specialists demonstrate the capabilities of manufacturability analysis. The initial electronic design is documented in systems magazine and the whole modified process further in this particular electronic system requires a very stable, well conducting it lightweight assembly structure. Further wishes are minimal microwave attenuation in critical areas and the ability to radiate excess thermal power. The electronics, when compared to the conventional separated mechanical and electrical design, further product improvements are based on the surface tolerance, alignment, coatings, or the method itself. Visualizing tools such as three-dimensional computer software packages are necessary for evaluation. Meetings and more accurate information about the electrical behavior of materials commonly applied in nation industry are needed. The deep interaction of mechanical and electronic design extended by manufacturability analysis can also lead to innovative solutions, adjusting the microwave skin depth by controlled oxidation of metallic surfaces. Design for manufacturing DFM evaluate the design from manufacturing perspective to identify areas that may pose challenges during production. This involves analyzing features such as part complexity, tolerances, material selection, and assembly requirements. Process selection determine the most suitable manufacturing process based on the design requirements and available resources. Consider process like machining, casting, molding, additive manufacturing, or a combination thereof. Production volume assesses the expected production volume to determine whether high volume, low volume, or custom manufacturing methods are most appropriate. High volume production may benefit from automation and economies of scale, while low volume production may require more flexible and manual processes. Material availability ensure that the selected materials are readily available in the required quantities and meet the necessary quality standards. Consider factors such as material cost, lead times, and potential alternatives if specific materials pose strains. Supply chain analysis evaluate the overall supply chain for the product. including sourcing of components and sub-assemblies. Consider factors such as supplier capabilities, lead times, cost, and potential risk associated with the supply chain. Equipment and tooling assesses the availability, the suitability of manufacturing equipment and tooling required for the production process. Consider factors such as equipment capacity, maintenance requirements, potential bottlenecks. Analysis evaluate the manufacturing cost, including materials cost, labor cost, equipment cost, tooling cost, and overhead expenses. Identify potential cost saving opportunities through process optimization, value alternative material choices, environment impact. Consider sustainability and environment factors throughout the manufacturing process. Identify areas where environmentally friendly practices can be implemented, such as waste reduction, energy efficiency, and the use of eco-friendly materials. Solution by conducting a manufacturability analysis and addressing the above considerations, systems engineers can optimize the design for efficient production, reduce manufacturing product quality, and minimize cost. Thank you, sir.